Whenever you're learning something new, it's important to know how to find help. One of the first suggestions that you'll get as you walk down this Linux path is that people are going to tell you to go to the internet and that Google is your friend. That's true, but you don't always want to have to search for hours at a time. So one of the things that I'm going to cover now is how to get help. And there are two ways that are built in. Most programs have their own help, and there's also something called the man pages. I'm also going to show you how to control input and output at the same time. Almost every command that you run is going to have some sort of help built into it. In this case, I'm using a -- help command to the ls program. And it's going to print a very brief summary of all the commands available as part of ls. So in this case, it's going to print a whole bunch of things. As you can see, it was too much to fit on one screen. So here's a quick trick. If you have too much on the output that you want to see, hold shift and hit page up, and it will go up page by page through something called the scroll back buffer. It stores a couple of hundred lines of history, whatever you've done on the current console. You can go all the way back to the beginning or whatever you have until the command history runs out. When you're done, just hit space. It'll flip back down to the prompt just like that. And then we can move on to a different way of doing this called the pipe. Piping is one of those things that's always scared new users, and that's very unfortunate. All that's really involved in a pipe is that it takes the output from one program, like ls, and uses as the input for another program, just as if you typed it yourself. And we'll go over that a little bit farther in a few minutes, but for now, let's take a look at a couple examples so you can understand what I mean. The first thing that I'm going to show is using the ls help output and then doing some more useful things with it. We'll start with another ls -- help, and then I'm going to immediately put in the pipe character. Now, the pipe character is the shift of the / key on most keyboards. It also looks like just a plain vertical bar. I'm going to go ahead and hit enter here, and you'll notice that instead of dumping a whole bunch of text like before, it dumped one screen worth of text and stopped. In the lower left, you'll see the word more. What just happened is that we took the output from the ls -- help command and piped it into a different command called more. Each time you hit space, it'll show another screen worth. And then when you're out of screen, it'll simply return you back to the prompt and reset your display. In addition to the help that normally comes in each program separately, there's also a set of reference material called the man pages. The man command will let you access a man page for any given application that's installed on the machine. From here, you can see you type man ls, and it will load up the command. And then you see a short listing of all of the things that you can do with it. Different man pages have different amounts of detail. Here, the man page for ls is pretty brief, but other man pages can be dozens or maybe even 100 pages long. When you're inside the man command, you can navigate around using normal navigational keys and Q to quit. Whenever I use a command during this entire set of videos, I'm rarely even going to touch on the surface of what most of them can do. If you're curious, check out the man pages for everything. It'll have every option that the command accepts, whether it needs files, what it can do with them, and a lot of times there'll even be examples. You, being the brilliant new systems administrator, have probably already determined that there are a ton of options to ls, and ls is one of the simplest commands available. It's going to fall to you as the viewer to explore these commands that I introduce more fully. So definitely highly encourage you to check out the help, highly encourage you to check out the man pages, and of course search on your favorite search engine. Figure out what the available commands can do. I can only introduce you to a limited subset, the ones that I think are most important or that show a concept. It's the concepts that are really the most important to learning how all this works together. But in case you're curious what sort by file size does for ls, it would be a great thing to do to try it by yourself after reading through the help. Time to get down to business. The first really complicated concept that we're going to have to cover is that in Linux, almost everything is treated as a file, and this includes devices. Now, you'll see the example that I have here is a SCSI hard drive or a SATA hard drive, dev SDA. What that means is that you can open your hard drive, which is the media, the storage media, in a text editor, in a hex editor. You can overwrite it, you can save to it, you can do anything that you want to with that file, just as if it were a text file, and it will do it to your hard drive directly. So you have to be wondering if this is a good thing, a bad thing, or just crazy. It's a little bit of everything. The most important thing to remember is that pretty much at no point is Linux going to save you from yourself. If you log in as the super user and decide to write zeros to the file that represents your hard drive, it will write zeros to it. The data will be gone. On the flip side, the powerful thing is you don't require any type of special programs to modify your hard drive with a hexadecimal editor. You can repartition it using just that file. You can go through the dev file system and look at every device on your computer if you need to. So let's do it. All of the devices are stored in the file system location /dev. Now I'm going to do an ls real quick, and what you're actually going to see is a listing of special files that represent all of the devices that are available in your computer, or at least in a theoretical computer. You'll also see that I used a special new pipe command again, with more. And as you look down through this list, there's a lot of things that probably are going to pique your interest. Something immediately worth noting is the FD0 entry, which represents your first floppy disk. As we keep scrolling through the entries here, we're eventually going to run into where your hard drives are listed. I'll pause the screen for a second so you can see what I mean. As you can see in the list here, there are actually 4 hard drives, the first one of which has a few partitions in it. I'll quickly finish running through the rest of the devices, and then it's time to introduce you to another command. The new command is going to help us look at this screen a little bit more clearly. Instead of having to scroll through a whole lot of output that may not pertain to us, instead we can use the grep command. Grep will take a pattern that you give it and search through all of its input to see if it finds it in there. At that point, it will display exactly the line that you're interested in, or lines, and then you can decide if that's what you're looking for or if you need to be more or less specific. I'm going to do the exact same thing as before, a long directory listing. But this time I'm going to use grep to only select the first hard drive so that I can see information specific to that. So as you can see there from the highlight, we only show things that say SDA plus something that says root on the right hand side. Now, as we expand out, you can see why that showed up. It's a special type of file called a soft link, which again we'll be covering later. The important thing to note is that since it has the text SDA, which is what we searched for, the line's still displayed. Another example, I'm going to search for the word 0, and there is a device called dev0, which is what I expect to see, and as I hit enter you can tell that 0 is in fact there. Just to stop using examples that are related around devices, I'm going to go ahead and change the directories into /etc or etc. Some people also say etc. In this directory is where you store configuration files that are system-wide. In a lot of ways it's similar to the Windows registry. But the first thing that we're going to take a look at is the password file, which stores user information like home directory, name, and the username. So let's check to make sure that the stuff actually in the etc directory first. So a big ls-l, and we'll see lots of pages of stuff once again. Should start to look familiar by now. Like always, when I'm expecting a lot of output, I'm going to go ahead and pipe it to more, and then we'll page through it with the space again. So there's a whole lot of listings here, and all of these are fairly interesting, but what we're really looking for is right here, the password file, which I've highlighted at the bottom. Now that we know that it's there, I'll go ahead and demonstrate how you can single it out so that you can get information on just what you're looking for. ls-l, then pipe it to grep with the word passwd, and it will show the files that match. Now, specifically, it's actually showing the lines that match the text input. So now let's take a look at what's in the file. You can see here is a list of all of the users that are on the system. I'm going to go ahead and scroll to the bottom here. I'm looking for a specific user, which is the student user, one that I created just for this demonstration virtual machine. And you can see some information about it. None of it's too important right now, but the two 1000s are the numeric user ID and group ID, which will be more important later. So now that I've seen that there is actually a line for student in there, I'm going to use grep to get information about it. So you can see that instead of doing ls-l and piping, you can also feed files and then the line that you're looking for directly to grep. So in this case, I said that I wanted to look for the word student in the file password, and it showed the exact entry that I was interested in. Sometimes you just want to take a quick look at a file without having to open a text editor. There's a command for that, and it's called cat, which is short for concatenate. So as you can see here really quickly, I'm doing cat password. And what we should expect to see is that the entire contents of the password file will be dumped to text on the console. Hopefully at this point you're thinking to yourself, hey, I could take this output from cat and pipe it to grep and search for an exact string that I'm looking for. And you would be correct, and you should probably try it right now. Let's take a further look at pipes.
As you may have guessed, the pipe command is kind of like a plumber's pipe, in that you can take output from one source and put it into the input of another source, just like you were routing water through a house. Coincidentally enough, these types of inputs and outputs in Linux are called streams, and every program has 3 that are available to it by default. One is the input stream, one is the output stream, and one is the error stream. They're called STDN, or standard input, standard output, and standard error. When you run the cat command, it's taking its standard output and dumping it to the screen. What you do with the pipe is tell it to take that standard output and redirect it elsewhere. So I'm going to show you an example with some graphics that hopefully help using ls. When you use ls without any type of output redirect, both the output and the error stream are directed to the console, just like you see here. And as you can see from my hopefully effective diagram, ls only has an output and an error stream when used that way. However, when you redirect input by using a pipe and say sending it to grep, what you've actually done is taken the standard output stream and sent it to the input stream of grep. And so the chart looks a little bit more like this. In the case of a pipe, what you've done is coupled the output from ls to the input stream of grep. Even though input isn't shown, it's implied because the output has to go somewhere. What I haven't shown you is that you can extend this output redirection almost indefinitely. So I'm going to add a third new command that I haven't introduced called tail, which shows by default the last 10 lines of output that it's given. So the same command as before, and then we add on an additional one at the end. And what's going to happen, we're adding one more step, as the chart shows, into the output redirection. So the output from ls is piped to grep, and the output from grep is piped to tail. Each step along the case can transform the text somehow. And you can see here from this example that we only got the last 10 lines of what was available before. And instead of showing the entire thing, we now have a little bit more concise view of what's going on. But let's say you want to save that output instead of just having it disappear forever after going to the screen. What you can do is a different type of output redirection that actually saves it to a file. And so as you can see here, I've used a greater than symbol and then given it a file name. And it's going to save all of the neat output that we just saw, and instead of putting it onto the screen, it's going to save it to a file. And you can see that I got a permission denied, which is an oops on my part, because I tried to save it to a directory that I don't have access to. So what I'm going to do is hit the up arrow, and I'm going to modify where I save it so that it goes into my personal home directory, which I should always have permission to. As you can see, it ran and didn't throw the same error. So let's check out the file and see what it looks like. What we should expect to see is the exact same output, but saved to a file. So we'll open it, and as you can see, it's the same 10 lines of text, which is a directory listing, that we saw before using just the output pipes. Once again, what we did was called output redirection, and you can do it either to the input of another program or out to a file using one of the redirect operators. Since this is a pretty basic and foundational topic, I'm going to go ahead and go through a couple more examples. You can see here that I have an empty directory, and I just opened a text editor called Nano, which I'm going to fill with a couple species of trees. And this is all for the example sake that we're going to come up with. And whenever you want to learn to use Nano, it has very helpful commands down at the bottom. I'm going to go ahead and save it out, and the first thing that I'm going to run is a tail with -n3 on the file. And -n is simply the number of lines that you want to display. Instead of just dumping to the screen, what I actually want to do is save the last 3 trees to a file. So I'll use the same command again, but then use the file redirect output operator and save it to a file called last3trees, which you can now see exists. Next, we're going to go ahead and cat that so that you can see that it actually contains the last 3 lines as were expected. If you'll remember from earlier, I said that each program has 2 output streams, the standard output and then also an error or diagnostic output. Let's take a look at how the diagnostic output looks, and I'm going to intentionally run some bad commands so that you can see what the errors look like. And then I'm going to show you how the error is separate from the output. As you can see from before, we still have the 2 files that I made in the last quick demo. So let's see what happens when we try to access a file that doesn't exist yet. In this case, I'm going to try to tail a file that I haven't done anything with, and it's going to throw an error message for me. That's kind of what we'd expect to happen. What we may not expect to happen is if we redirect the output, it's still going to display the error message. Now, you may have expected that error message to go into the file, but this is demonstrating what we call the standard error. And the error output is distinct from the normal output so that you can specifically look for it when you're doing things. That way you have diagnostic information even though you've saved the output to a different file. As we go through this really quick here, what I've done is add a special modifier to the output redirect. The number 2 is signifying that it needs to redirect the error output. And as you can see, when I hit tail with 2 in place, it wrote a file with the diagnostic output in the file instead. It may seem a little counterintuitive, but what it means is that when you run a command, you can save the output in one file, and the error diagnostic information can either be saved to a different file or you can have it display on the screen. This way they don't get mixed up, and you can get an idea of what's going on in the background a little bit better. That's a wrap on basic output redirection. We're going to continue to use this a lot, so if you still haven't quite mastered it, that's fine. We'll just go and use examples as we continue on. In fact, we might just use it a lot as we move on to user and group management.